Okay, let's go over this one. So here, every x, so here's my x, here's its probability. So negative 8,000 times 0.3 plus the next one, 15,000 times 0.7. So you guys got negative 2,400 plus 105,000, is that right?
10,500, yeah.
So when you add those, you end up with 8,100 is his expected profit. Good. Someone else had said they wanted to go over number 7. Whoops. So number 7, hand me number 7. Thank you. Is, yes, the fire department records how long it takes for each of its trucks to reach the scene of a fire. The distribution of arrival times is uniform. So I'm looking at a rectangle. With a probability of 0.1 for any arrival time between 2 and 12 minutes. What's the probability a truck will reach the fire scene within 5 to 9 minutes? So trying to find probability in 5 and 9. So first of all, what's my height have to be? What's my length of the whole rectangle?
4.
The whole rectangle.
10.
10. See what I'm saying? Thank you so much. From 2 to 12, my length is 10. Because if I'm at mile marker 2 and I walk to mile marker 12, I walked 10 miles. So since this whole area has to equal 1 or 100%, if this is 10, the height must be 1/10. Good? All right, great. So I now want to find this little small rectangle, this area. I know my height is 1/10. What's my length?
4.
5 to 9. And remember, the beautiful thing about the uniform distribution is find the probability. Probability is just the area of a rectangle. Because remember, probability is the same thing as area under the curve. So if my area is just a rectangle, it's super simple, right? Area of my area equals my probability, right? So this is just length times height, which is 4 times, I'll put the dot because you guys like the dot better, 1/10. If you multiply those, you get 0.4. So 40%. 40% chance that you arrive, and it takes them between 5 and 9 minutes to arrive. When we say 5 to 9 minutes, they mean exactly 5 minutes to exactly 9. Right. Okay, good. Was there another one people wanted to go over? Do you guys have more questions about that one?
Can we do number 22?
22? Sure. Membership in an elite organization requires a test score in the upper 30%. This is a good one. Upper 30%. If mu is 115 and sigma equals 12, find the lowest possible score, acceptable score that will allow a candidate to apply. Assume it's normally distributed. Did you guys see that part? Normally distributed. So you're going to know it's going to be this. Great. Put your little notch in the middle. Now, where's my mean? Mean is 115, I don't have an x value. I can't find a z-score. Oh, wait, that's because I'm trying to find the x value in the z-score. What'd they give me? And the standard deviation of the mean, which they have to give me. It's normal. Normal, we have to give you the mean and standard deviation always. But what's the other thing they gave me? They didn't give me an x. There's no n.
They gave us a z.
They didn't give me a z. Where's the z? Number 22. Where's this number 22? Upper 30%. What's upper 30%? It's not a z-score. Is that an x value?
Area.
It's an area. They gave me an area. Upper 30%. So this is going to be, wait, is this side or that side?
Right side.
Upper 30%. They gave me this in here. Do you guys see what I'm saying? So this is that flip one. So instead of finding, whose is this?
Mine.
Oh, great. Instead of finding an area, they gave me the area. This is the opposite of the inverse of what we usually do. Right? So here, I need to find the z-score and then convert the z-score to an x value. So what do I use to go from areas to z-scores? What's the command? Inverse norm? But wait, I need to feed it an area, but not the, I need to feed it the left area. Yeah, so if my right area is 30, what's my left area? 70. And what do we get when we do that? 5244. Okay, so I'm going to round that to 0.2 decimal places, 0.52. And that's the z-score. Everybody good with that part? But I'm not done, because I'm not going to say, oh, buddy, you need to have a z-score of 0.52. He says, well, what score is that? I need to convert that to
X.
Yep, to x. So my x, and you can just do it the regular way. Z equals x minus mu over standard deviation, right? So my z is 0.52. My x, I don't know. My mean is, what was my mean? 115?
150.
115? And my standard deviation was 12? So I multiply 12 by both sides. Or are you guys better with the formula? Is it better with the formula? That's right. Multiply 12 by both sides. So times 12 times 12. So then we get 12 times that, 6.24 equals x minus 15. So then I'm going to add 115 to both sides. And I will get x is equal to 121.24. Good. Yeah.
Back to the first step, to the inverse norm, when
Uh-huh.
given the area,
Yeah.
I put in both numbers and I still get the same.
No, you don't. If you put in 30, you get negative 0.52 because it's symmetrical. So 30% over here would give you negative 52. And you could do that, but then you better realize that you need to switch it over and make it positive because it's symmetrical. So you absolutely could do that. So what Ulysses was saying, if you put in 0.3, then it gives you negative 0.52. Which you can totally do that. Just put in this over here, but remember that it's symmetrical, so then this becomes positive 0.52 in your z-score. Yeah. So you can do that also. And if you have a fancy schmancy calculator, then you can just put in 0.30 and just it gives you the option of left or right and say, oh, that's the right area. And you can choose right instead of left, and it'll just automatically do that to you. Does anybody have one of those? Let's see what it is here, but yeah. And instead of this, you could also use the other formula I gave you, which is just simplified for x, right? X equals your mean plus the number of standard deviations you want times the standard deviation, right? So that would be 115 plus my z-score 0.52 times the standard deviation. So you can just do it that way too, because that totally makes sense. Because what is my x value? It's how many standard deviations I am, away from the mean. So you find out how many standard deviations you are away from the mean, and you add it to the mean, and that's your x value. Okay. Another problem? We have time for one more before we go. The last one? What's the last one?
23.
Is the same thing inverse now?
The last one.
No. He's talking about 23, not the
Complete the
last one.
sentence. Okay. Okay. The second to last one. In a recent year, the average movie ticket price costs, this is 23. Here, Felicia, can you read it for me?
Okay, so 23. In a recent year, the average average price movie ticket cost $7.89. In a random sample of 50 movie tickets from various areas, what is the probability that then mean cost exceeds $8, given that the population standard deviation is 139? And it says draw a picture and central limit theorem.
Right. So, do you guys see the sample part? Has a sample of how many? 50. So I have an n of 50. All of a sudden, you darn well be thinking central limit theorem. Because I have a mean and I have an n. Right? So once I have a mean and an n, that means it's central limit theorem. Mean and standard deviation means normal distribution. So it's normal distributed, but it's also central limit theorem because I have an n of 50. So I want to find that the average, for the probability of the average price, that x bar is what?
Cost $8.
$8 or more than $8? More than $8. Okay, so I need to find my sigma x bar, first thing. It's the first thing I should be thinking. So number one, find your sigma x bar. Step two, find your z-score. It's terrible. And then three, give me a picture. And then four, find the area, find the probability. So sigma x bar, how do I find that, guys? Yep. Over. Is that? Square root of n. 1.39 over square root of 50. So that's like 0.19 something?
966.
667 or 6667? Like that? Okay, go around.
657.
657.
Yeah.
Okay, so 66 when you're round. Okay, good. And then my z-score, right? Do you guys find the z-score yet?
No.
Okay. Find the z-score, draw a picture, find the probability. I'll move this one back. That's okay. Whatever your court's name.
Should you guys finish?
So z-score, make sure you use your new standard deviation. You can use 2.0 if you want. You can use 1.97. Either one's fine. I think you should give yourself, I'd say 3 sig figs, so maybe 1.197. Do you guys like that better? That's fine. I'm okay with that. Totally.
For trying to find number 2, is it x minus
0.2877.
or x minus mu over
The
sigma?
new sigma. Because, so you guys, heads up guys, we just computed this. That means we should use it. If we don't use it, it's just sitting there for no reason whatsoever. We computed it because you need to use this instead. Right? So when you use a z-score, it's z-score is x minus mu, it's x bar minus mu over sigma, but not the regular sigma, the new sigma x bar. So that's going to be, this is crap, this is total garbage. It's going to be x, 8 minus 789 divided by 0.197. What did you guys get for that?
5.56.
5.56?
Yeah.
Great. So then you do a picture. And is it less than or more than?
More than.
More than to this side over here. And then you guys do the last step, probability. How do you guys do the probability, or have you guys done it yet?
Normal CDA.
84. We'll use somebody's grandmother's age. Any large number.
200.
200. Sure, 200. Okay. Whatever you want.
Yeah.
What did you guys get?
0.2877.
Wait, what?
2877.
So, just to be clear, this here is 0.2877. This is my z-score, and my x value that goes with this is $8. So this is 0.56 is the same thing as $8. Okay, that is it. And then if you're describing it, you'd say that 28.77% of people, or of the time, the average of 50 would be over $8. Okay, so again, quick reminder, class exam on almost 99% chance, or maybe even greater than that, of having the exam on Tuesday. But Thursdays will be online. Yeah.
Or next?
No, nothing tomorrow. So there's nothing tomorrow, unless you're in the afternoon class. The afternoon class, they'll have the thing you guys did yesterday, they'll have that one tomorrow. You guys don't have anything to your exam on Tuesday. And if some of you want, I think I could probably stagger it and have some exams on Tuesday and some exams on Thursday, so we reduce the number of people. We're trying to reduce the number of people in a room at one time, reduce the density. So half you guys one day spread out, the other half the other day spread out.
And the lab still on Tuesday?
The lab is